Picture a vast open plain somewhere in the American West. The wind moves through the grass in long, slow waves. A herd of wild horses stands at the edge of a shallow creek, drinking. A quarter-mile away, a massive bison bull lifts his heavy head and watches them. He doesn't charge, he doesn't flee, he simply watches, and then, almost deliberately, he begins walking in their direction. The horses don't scatter. A few ears swivel toward him. One mare takes a few steps sideways. And then the whole scene settles again, both species grazing within a few hundred yards of each other, moving in the same general direction, like two rivers that have decided to follow the same valley. This happens every single day across the grasslands of North America, and almost nobody has ever stopped to ask why. Most people who see it assume it's coincidence. Two big herbivores, same habitat, same water sources, just happening to be nearby. But that explanation falls apart the moment you start looking at the details. Because what's happening between wild horses and bison is not coincidence. It is coordination. It is, in the most literal ecological sense, a two-species protection system, one that has been operating across these landscapes for thousands of years, and one that modern observers have only recently begun to understand in any real depth. If you want to understand something this extraordinary, stay here. Hit subscribe so you never miss something like this again. The first thing you need to understand is that wild horses and bison did not arrive at this relationship by accident. Everything in ecology that looks convenient has been shaped by pressure, by predators, by drought, by fire, by the brutal arithmetic of survival, where every calorie spent on vigilance is a calorie not spent on growth or reproduction. Relationships between species only persist when they offer a genuine advantage to both parties. So the fact that horses and bison seek each other out, the fact that their movements overlap in ways that go beyond the random, tells you immediately that there is something real happening here. And there is. Let's start with the most obvious piece of the puzzle. Detection, the ability to know that something dangerous is approaching before it arrives. On an open plain, survival often comes down to a single question. Who sees the predator first? Wolves hunt in coordinated packs. Mountain lions stalk from cover. Coyotes test the edges of any herd, looking for weakness. Bears appear with surprising speed out of draws and timber. For any single animal standing on flat grassland, the challenge is the same. You need eyes and ears covering as many directions as possible, as far out as possible, for as much of the day and night as possible. A lone horse cannot do this. A lone bison cannot do this. But a mixed group of horses and bison absolutely can. Horses and bison have fundamentally different sensory architectures. A horse has eyes positioned on the sides of its head, giving it an extraordinary wide-angle view of the world. Almost 360 degrees of vision, with only a small blind spot directly behind and a narrower zone of binocular vision in front. A horse standing in a field is essentially scanning a vast circle of landscape simultaneously. It detects movement. It detects shapes at the edges of its visual field with extraordinary sensitivity. Any flicker, any shift in the grass, any shape that doesn't belong registers immediately. Horses are also acutely sensitive to sound. Those large mobile ears rotate independently, sweeping in different directions, sampling the acoustic landscape continuously. And horses smell the world in ways we barely comprehend. The sense of smell in a horse is orders of magnitude more sophisticated than in humans, capable of detecting the chemical signatures of predators carried on wind from distances that seem almost impossible. Bison have a different, but equally impressive sensory profile. Their vision is similar in layout to the horse, wide angle and attuned to movement, but their most powerful sense is smell. A bison's olfactory system is legendary. They have been documented detecting water from miles away, tracking weather systems by scent, and identifying the chemical markers left by wolves long after the wolves have moved through an area. Their hearing is excellent and oriented toward lower frequencies, picking up the kind of distant, low rumbles and ground vibrations that shorter-range senses might miss. And bison are profoundly attuned to changes in behavior within their own group, the kind of collective vigilance that comes from living in herds of thousands for millions of years. When horses and bison graze in proximity, these two different sensory systems overlap and reinforce each other. A horse might catch a visual flicker in the grass at 200 yards that a bison hasn't registered yet. A bison might catch the scent of a wolf that hasn't yet moved into the horse's visual field. Together, they cover more spectrum, more distance, more time. The effective surveillance radius of a mixed group is simply larger and more comprehensive than either species can achieve alone. This is not a trivial advantage. In a world where predators are real and regular, every additional second of warning translates directly into survival. A horse that gets a 4-second head start on a wolf versus a 2-second head start is a horse that lives to breed. And in evolutionary time, those horses that consistently put themselves in situations offering better warning lived longer and passed on more offspring. The behavior, seeking proximity to bison, became reinforced across generations simply because it worked. But the detection advantage is only the beginning, because the relationship between these two species goes considerably deeper than who sees the wolf first. Consider how predators actually work. A wolf pack approaching a large mixed herd doesn't just see prey, it sees a problem. Specifically, it sees a coordination problem of enormous complexity. Wolves are intelligent, adaptive hunters. They read their target animals constantly, looking for the one that's limping, the one that's separated, the one that responds slowly, the one that hesitates when the group moves. They probe, they test, they create pressure, and watch for weakness. Their hunting strategy depends critically on identifying the vulnerable individual and isolating it. Now, when you have a mixed herd of horses and bison, you have created a situation where the wolves have to process two entirely different species simultaneously. Horses and bison respond to threat in fundamentally different ways. A horse's primary strategy is to run. Fast, sustained, coordinated flight, with the herd exploding outward in a burst of speed that is genuinely difficult for a wolf to penetrate effectively. A bison's primary strategy involves a combination of flight and, critically, defense. Bison don't simply scatter, they will turn. They will form defensive clusters. The bulls especially will position themselves between predators and the vulnerable members of the herd. A bison bull that turns to face a wolf and drops its massive head is presenting 1,000 pounds of muscle, horn, and pure willingness to injure something. Wolves know this. They have learned it across thousands of generations of coevolution. They treat bison bulls with considerable respect. When horses and bison are in proximity and a predator attacks, the two different responses play out simultaneously, and the result creates a kind of tactical complexity that is genuinely difficult for predators to manage. The horses scatter with explosive speed, drawing some predator attention outward. The bison cluster and counter-threaten, creating a defensive anchor that resists the kind of directed pursuit that wolves use to run down horses. The wolves are suddenly facing two different tactical problems at once. Chase the fleeing horses and risk the bison creating a defensive group that blocks access to vulnerable individuals, probe the bison cluster and let the horses escape, focus on one species entirely. Every one of these choices creates trade-offs, and trade-offs cost the predators time, energy, and hunting success. There is solid evidence from historical accounts and from modern observations of feral horse populations near bison that predation rates on both species are lower when they are in proximity than when either species is alone. The mathematics of mixed herd defense are genuinely favorable, not by a small margin, but by amounts that matter in real ecological terms. And then there is the land itself. Because the relationship between horses and bison is not just about predator detection and defense. It runs all the way down into the grass, into the soil, into the structure of the landscape that both species depend on. Bison are, by any measure, one of the most powerful ecosystem engineers that grassland habitats have ever produced. A single bison bull weighing 1,800 pounds processes an enormous amount of grass every single day. Multiply that across a herd of any significant size, and the effect on the vegetation is massive and, critically, it is a specific kind of effect. Bison graze intensively. They eat the tall, coarse grasses down to the ground in areas they choose to occupy, creating short grass patches in what would otherwise be uniform tall grass prairie. These short grass patches are not random. Bison tend to return to them, preferentially grazing areas that are already short, maintaining them in that condition through regular use. They wallow in these areas too, churning the soil, creating depressions that hold water, disturbing the ground in ways that promote the germination of certain plant species and suppress others. Horses graze differently. Where bison tend to clip things short and return to the same patches, horses are more selective and more mobile. They preferentially take the most nutritious plant material from a wider area, often moving on before they've exhausted an area, leaving behind a patchwork of partly grazed vegetation. They also have a different effect on grass structure. because of their longer, more mobile lips and different jaw mechanics. Horses can graze a patch that bison would consider already done, accessing plant material at heights and levels of coverage that bison leave behind. The consequence of these two different grazing styles operating in the same landscape is a mosaic, a patchwork of different grass heights, different vegetation compositions, different structural complexity across the plain, and that mosaic is ecologically productive in ways that uniform tall grass or uniform short grass could never be. Different grass heights support different species of small animals. Different plant compositions support different insects. The wallows create micro-wetlands. The disturbed soil patches create germination sites. The structural diversity of the landscape supports a far richer food web than either species could create alone. But here's the piece that connects directly back to the horse-bison alliance. That mosaic also benefits both species directly. The short grass patches that bison maintain are highly nutritious. Repeated grazing stimulates the plants to produce new growth continuously, and fresh grass growth is richer in protein and more digestible than the mature, fibrous stalks of long ungrazed areas. Horses, who are selective grazers, actively seek out these high-quality patches. They benefit directly from the grazing work that bison have done, and in return, the horses' more mobile, selective grazing of the wider landscape reduces competition for the specific short grass zones that bison prefer. They're not competing for the same bites of food. They're using the same landscape in complementary ways, each improving it for the other. This is the kind of relationship that ecologists call mutualism, where both species benefit from each other's presence. In its most developed forms, it approaches something that looks almost like cooperation, even though no conscious agreement is ever reached. It emerges from the accumulated behavior of generations, shaped by the simple fact that animals which happened to behave this way survived better than animals that didn't. The grazing mosaic also has implications for fire, and fire matters enormously on a grassland. Tall, dense, dry grass is highly flammable. In a landscape without significant structural variety, a fire that starts can move with terrifying speed across enormous distances. But in a mosaic landscape, where patches of different heights and densities are interspersed, fire doesn't move uniformly. The short grass patches, which have been grazed down by bison and selectively used by horses, act as natural fire breaks. Fire that hits a short grass patch loses energy and often stops or slows. This patchwork structure, maintained by the combined grazing pressure of horses and bison, effectively limits the scale and intensity of grassland fires, which is of direct benefit to both species. Now let's talk about water, because water, on a grassland, is not evenly distributed, and the ability to find it, to know where it is before you can see it, is a survival skill of the highest order. Bison are exceptional at this. Their sense of smell allows them to detect water sources at extraordinary distances, and their behavioral history on North American grasslands spans hundreds of thousands of years, during which they accumulated, in the collective memory of herd behavior, an intimate knowledge of the landscape. Bison herd movements, even in unfamiliar territory, tend to track toward water with a reliability that appears almost uncanny. Wild horses, especially feral populations that have only recently re-established themselves in a landscape, don't always have this depth of landscape knowledge. But they don't need it, because they can follow the bison. The practice of horses following bison movements has been documented repeatedly by observers working with wild horse populations in areas where bison are also present. Horses will track a moving bison herd across considerable distances, apparently following them toward water sources that the horses could not have located independently. This is not a simple stimulus-response behavior. It requires that the horses have learned, presumably across multiple generations of horses in contact with bison, that following bison herds is a reliable way to find water. That is a learned behavioral tradition, a piece of ecological knowledge passed from experienced animals to younger ones, and it represents a genuinely sophisticated form of interspecies information transfer. In return, the horses that have followed bison to water often end up watering at different times or at different points along a water source than the bison themselves, partly because the social dynamics at a water source are complex, and horses and bison have worked out, through experience, how to use the same resource without generating too much conflict. The result is that the water source itself experiences less concentrated pressure from any single species, which is actually beneficial for the recovery and maintenance of the water feature itself. Drought changes everything. In a dry year, water sources shrink and disappear. Grass becomes sparse and nutritionally depleted. The calculus of survival shifts dramatically, and it is under drought conditions that the horse-bison relationship shows some of its most striking dynamics. Bison have survived the Great Plains of North America through multiple drought cycles over hundreds of thousands of years. Their behavioral flexibility, their ability to move great distances, their knowledge of where the last water is likely to persist, is among the most refined of any large herbivore anywhere on Earth. They are, in the most literal sense, masters of drought navigation. Horses, with their speed and endurance, can cover the distances that drought requires. But without the landscape knowledge that bison carry in their collective behavior, horses can make costly mistakes, moving in the wrong direction, exhausting themselves, ending up in areas where resources are no better than what they left. When horses maintain their association with bison through a drought period, they essentially gain access to the bison's landscape intelligence. They follow movements that bison have calibrated, perhaps across hundreds of miles, toward the places where grass and water persist longest. This isn't parasitism. The horses aren't taking anything from the bison. Their presence alongside the bison actually helps maintain the shared vigilance system that protects both herds from predators that are also under pressure during drought, and, accordingly, more desperate and more dangerous. There is another drought-related dynamic that is less immediately obvious but equally important. Bison hooves are powerful. When bison congregate around a diminishing water source, their movement in the soft mud around it creates depressions, churns up the substrate, and can actually cause groundwater to move toward the surface in ways that extend the life of a small water feature. Horses, with different hoof structures and different movement patterns, don't create quite the same effect. But horses that are drawn to the same water features as bison benefit from whatever the bison's presence has done to extend or maintain that water source. During the peak of the great bison herds, before European settlement reduced their numbers to near extinction, estimates of bison populations run to tens of millions of animals. In that world, the relationship between horses and bison was operating at a scale we can barely imagine today. Vast herds of wild horses, which had coexisted with bison on the North American continent through multiple glacial cycles, were moving across the same landscape in complex, overlapping patterns with bison herds that could number in the hundreds of thousands. The sensory web that this created across the grassland was essentially planetary in scale. A predator attempting to approach any part of that landscape would have been detected, signaled, and responded to almost before the thought had formed. The signal systems themselves are worth examining in detail, because horses and bison have evolved specific behaviors for communicating danger, and some of these behaviors are readable across species lines in ways that matter. When a horse detects something alarming, its behavior changes in ways that are immediately visible to other horses and also visible to bison. The head comes up, the ears lock forward toward the threat, the body stiffens, nostrils flare, the tail may lift slightly. These signals cascade through a horse herd almost instantly. A horse that sees another horse in that posture will immediately orient in the same direction and adopt the same alert posture, even before it has identified the threat itself. The behavior propagates through the herd in seconds. Bison respond to these horse alarm signals. This has been observed directly and repeatedly. A bison bull that sees a group of horses suddenly lift their heads and orient in the same direction will stop grazing and orient in that direction too, well before it has detected the threat independently. The bison are reading the horses as an early warning system, and the information is genuinely useful to them. By the time the bison have confirmed the threat through their own senses, the valuable seconds provided by the horse's visual alarm have already been gained. The same process works in reverse. Bison that become suddenly agitated, that shift direction without apparent reason, that produce the low, resonant grunts and snorts that indicate alarm, communicate that agitation to nearby horses. Horses are exquisitely sensitive to the emotional state of other animals. It's a sensitivity that makes horses extraordinarily difficult to deceive. They read microsignals in posture, movement, and vocalization that would be invisible to human observers. When bison in the vicinity show signs of alarm that are driven by chemical detection of a predator upwind, horses that haven't yet smelled or seen anything will begin to show their own alert responses within seconds of the bison signaling. The cross-species information transfer is rapid, reliable, and clearly functional. What makes this particularly remarkable is that horses and bison are not closely related. They don't share a common recent ancestor, don't communicate in the same language, don't share the same fundamental social organization. And yet they have, through the long pressure of shared predators in a shared landscape, developed the ability to read each other's alarm signals with sufficient accuracy to gain survival benefits. This is convergent behavior at a remarkably sophisticated level. The social structures of the two species also interact in interesting ways. Wild horses live in small, stable family bands centered on a lead mare and, typically, a dominant stallion. These bands have persistent membership and strong social bonds. Individual horses know each other intimately and respond to each other's behavioral states with great precision. Within a band, communication is rich and continuous. Bison live in much larger, more fluid aggregations. The basic social unit for bison is a group of females and young, with bulls living separately for much of the year, and joining female groups primarily during the rut. Bison herds are not stable in membership the way horse bands are. Individuals move between groups, and the cohesion of a bison aggregation depends partly on simple proximity and partly on shared behavioral responses to environmental conditions. When horse bands associate with bison groups, the horses don't dissolve their own social structure. The band remains intact, moving as a unit, maintaining its own internal hierarchy and communication. But the band as a whole navigates relative to the bison group in ways that suggest genuine awareness of the bison as a reference point. Lead mares in particular have been observed making movement decisions that are influenced by the direction and pace of nearby bison travel, essentially using the bison herd's movement as information about the landscape. The stallion's role in all of this is also worth examining. A stallion's primary function in a wild horse band is reproduction and protection. He monitors the landscape for threats, challenges rival males, and shepherds his mares and foals away from danger. When a predator is detected, it is often the stallion who places himself between the threat and the fleeing band, slowing pursuit through active confrontation in ways that are genuinely dangerous for him. Stallions have been killed or severely injured by wolves in this kind of rearguard defense. When the band is associated with a bison group, the defensive burden on the stallion is somewhat reduced. The presence of large bison bulls with their own willingness to turn and face a predator creates additional layers of defense that the stallion alone could not provide. The effective defense of the mixed group is greater than the sum of its parts, and the stallion, while still playing a central protective role, is operating within a much more robust defensive architecture. Foals are the most vulnerable members of any horse band. Newborn foals can run within hours of birth, a remarkable adaptation to life in predator-rich grasslands, but their speed is limited for the first weeks of life, and they lack the stamina for extended flight. Predators know this. Wolves targeting a horse band will often focus their attention on separating a foal from the band during the chaos of an attack. The stallion's defense and the band's tight formation are the foal's primary protection. In a mixed setting with bison, a foal gains something additional. The sheer physical mass of a bison herd creates a barrier that wolves approaching from any given direction must get through or around before they reach the horses. Bison bulls that have calves of their own to protect are especially vigilant and especially aggressive toward approaching predators. Their defensive postures and active threat responses toward wolves create a buffer that gives horse foals additional time and space to achieve distance from a predator. Foal survival rates in situations where horse bands associate with bison appear, from observational evidence, to be higher than in bands that have no such association. This matters enormously in evolutionary terms. Foal survival is one of the most significant factors in the long-term reproductive success of a mare. A mare that consistently raises more foals to independence than her peers will, over her reproductive lifetime, contribute disproportionately to the next generation. If the behaviors that increase foal survival include actively seeking proximity to bison, those behaviors will spread through the population because the mares and offspring that carry them will be more numerous in each succeeding generation. This is how natural selection works, not through any conscious plan, not through any grand design, but through the simple arithmetic of who survives and who breeds. Over thousands of generations, the horses that happened to seek bison proximity survived better, bred more successfully, and passed those tendencies to their offspring. The bison, simultaneously, that tolerated and perhaps sought horse proximity, gained their own survival advantages. Both sides of the relationship were selected for, simultaneously, across deep time. There are other dimensions to this relationship that involve the physical structure of the land in ways that go beyond grazing patterns. Bison create wallows, depressions in the ground produced by repeated rolling and pawing that become important microhabitats. These wallows collect rainwater and hold it longer than the surrounding ground. In dry conditions, they persist as water sources long after surrounding areas have dried out. They support specialized plant communities around their edges, attract insects, and create habitat for birds and small animals. Horses use bison wallows. They drink from them and sometimes roll in them. The wallows, created by bison's physical behavior, become a resource that horses access. Horses, in turn, create trail networks. Wild horses are systematic movers. They develop and maintain trails through repeated use that connect grazing areas, water sources, and resting places. These trails compact the soil, create movement corridors, and persist in the landscape for years. Bison use horse trails. The narrow, horse-created pathways through rough terrain or dense vegetation become routes that bison incorporate into their own movement patterns. The trail network created by horses navigating a complex landscape becomes infrastructure that benefits bison movement through that same landscape. This sharing of physical infrastructure, wallows moving from bison to horses, trails moving from horses to bison, represents another layer of mutualism that is easy to overlook when you're focused only on predator detection and defense. The two species are, in a real sense, improving the physical landscape for each other through their individual activities, creating resources and pathways that neither would create for the other intentionally, but that both use opportunistically and beneficially. There is also the question of insects. Both horses and bison are heavily parasitized by a range of blood-sucking insects, flies, midges, mosquitoes, and various species of biting fly that cause considerable discomfort and can transmit disease. Large grazing animals in grassland environments deal with this insect burden in various ways. They move to areas with more wind. They stand in water. They aggregate, which at first seems counterintuitive, since more animals in one place would logically support more insects, but which actually works, because the insects are somewhat confused by a large mass of animals, making it harder to lock onto any individual target. When horses and bison are together, the mixed species group creates a complex aggregate that is, from the perspective of many parasitic insects, harder to navigate than a single species group of the same total size. Different body temperatures, different chemical signatures, different movement patterns within the group confuse the directional cues that biting flies use to find targets. The insect burden per individual animal appears to be reduced in mixed species groups compared to single species groups of equivalent size. For horses, which suffer considerably from certain species of flies that are not major pests of bison, and for bison, which have their own specific parasites, even modest reductions in insect harassment translate into real benefits. Less time spent in flight from insects is more time spent grazing. Less blood lost to parasites is more energy available for growth and reproduction. The birds know this. The relationship between large grazing animals and the birds that follow them is one of the most visible and well documented in ecology. Cattle egrets follow cattle. Oxpeckers follow Cape buffalo. The grasslands of North America have their own versions. Cowbirds, originally following bison across the plains, picking up the insects disturbed by large hooves and the parasites that bison carried, are a classic example of this three-way relationship. When horses and bison are together, they create an even richer foraging opportunity for these bird followers, and the birds that follow them return the favor by eating parasites directly off the animal's skin. This is cross-species mutualism operating at multiple levels simultaneously, and the horse-bison relationship sits at the center of it. Now, let's bring this into the present, because understanding this relationship historically is interesting, but understanding it in the context of the modern world is where things become genuinely urgent. Because wild horses and bison both exist today in radically diminished, fragmented, and managed landscapes, and the relationship between them is under pressures that it has never faced before. Bison were reduced from perhaps 60 or 70 million animals to fewer than 1,000 by the late 19th century, one of the most catastrophic faunal collapses in recorded history. They have since recovered somewhat, with conservation herds now numbering in the hundreds of thousands, but the vast majority of these are in managed situations, behind fences, on protected land, not roaming freely across the open landscape the way they once did. The great herds, the ones that shaped the grassland from Mexico to Canada and from the Rockies to the Mississippi, are gone. Wild horses, specifically the feral horses that descended from domestic animals that escaped or were released over the past few centuries, known in the United States as mustangs, exist in several western states in populations that are intensely managed and contentiously debated. The Bureau of Land Management oversees these populations and conducts regular roundups to control numbers on the grounds that the horses compete with cattle and damage rangeland. The ecological arguments around Mustang management are complex, contested, and politically charged. But one of the least examined aspects of those arguments is what happens to both horses and the broader ecosystem when horses and bison are no longer present in the same landscape together. On the few areas of land where both feral horses and bison coexist without heavy management intervention, the patterns are striking. The horses and bison associate in ways that are consistent with everything the historical and ecological record would predict. They graze in proximity. They show cross-species alarm responses. The grazing patterns of the mixed group produce the kind of vegetative diversity that supports richer grassland ecosystems. The predators in those areas, where wolves or mountain lions are present, show hunting behavior that reflects the greater difficulty of targeting either species when both are present together. On lands where horses and bison have been separated, either by removing one species or by managing them in separate areas, the dynamics that the mixed species association produces simply don't happen. The grassland lacks the structural diversity that combined grazing would create. Predation pressure on whichever species remains is higher because the multi-species vigilance system has collapsed. The water features, the trail networks, the insect dynamics, all of the layered mutual benefits cease to operate. This has real consequences for the restoration of grassland ecosystems, which is one of the central conservation challenges in North America right now. Grasslands are among the most threatened ecosystems on the planet. The Great Plains of North America have lost more than 70% of their original extent to agriculture and development. The grasslands that remain are often degraded, fragmented, and biologically impoverished compared to their historic condition. Restoring them is a priority for any serious approach to conservation, and it requires understanding what made them function. The horse-bison relationship was a central functional element of the North American grassland system. Not a peripheral detail, not an interesting footnote, but a core ecological dynamic that shaped the vegetation, the soils, the water distribution, the predator-prey balance, and the overall biological productivity of the landscape. Restoring functional grasslands without understanding this relationship is like trying to restore a rainforest without understanding the relationship between figs and the animals that disperse their seeds. You can plant the trees, but you can't recreate the function without the interactions. There are now serious proposals in conservation circles for what are called rewilding initiatives, large-scale restoration of grassland ecosystems with full suites of native species. The American Prairie Project in Montana is one example. The American Serengeti concept, which envisions restoring vast areas of the Great Plains with bison, wild horses, wolves, and the full complement of grassland species, is another. The horse-bison relationship is, implicitly or explicitly, a central element of these visions, because anyone who has looked seriously at the historical ecology of these grasslands understands that these two species went together, that their co-occurrence was not accidental but functional, and that the ecosystem they jointly created was richer, more resilient, and more productive than what either could create alone. There is also a deeper evolutionary context to explore here, because the horse-bison relationship did not begin in recent centuries. It reaches back to the Pleistocene, the great age of grasslands and megafauna, when North America looked very different from today. Horses evolved in North America. This is a fact that often surprises people, because we associate horses with the Old World, with the steppes of Central Asia, with the domestication processes that produced the breeds we know today. But the horse family originated in North America approximately 55 million years ago. It diversified here, evolved here, and produced the ancestors of all modern horses. Through the Pleistocene, multiple species of horse roamed the grasslands of North America alongside giant bison, which were themselves considerably larger than modern bison. The relationships between these species in that ancient grassland ecosystem would have been, if anything, even more complex and entrenched than the relationships we see in modern descendants. The behavioral traditions that connect horses to bison, the tendency to seek proximity, the cross-species communication, the complementary use of resources, these are not recent innovations. They are the surviving echoes of an ecological relationship that has been developing and deepening for millions of years. Horses went extinct in North America at the end of the Pleistocene, approximately 10,000 years ago, along with most of the other large megafauna of the continent. The causes of these extinctions remain debated, with climate change and human hunting both playing roles in most modern assessments. Bison survived. The particular species of bison that exists today, bison, is the survivor of that great extinction event, carrying forward the behavioral and physical adaptations that allowed it to persist when its contemporaries did not. When horses were reintroduced to North America by Spanish explorers in the 15th and 16th centuries, they were returning to a continent where, until very recently in geological terms, horses had always been. The grassland ecosystems of North America had been shaped for millions of years by horse grazing. The plants had co-evolved with horses, the soils had been structured by horse movement, and the bison, whose ancestors had shared the landscape with horses for millions of years, retained whatever behavioral legacies that long association had produced. The rapidity with which feral horses re-established themselves across the Great Plains after the Spanish introductions, and the speed with which they integrated into bison-dominated landscapes, is entirely consistent with this view. These were not animals entering a foreign system. They were returning to a system where their ecological role was, in some sense, already waiting for them. The grazing niche they filled, the behaviors they expressed, the relationships they formed with bison, these were echoes of something ancient, reactivated when the opportunity arose. The indigenous peoples of the Great Plains recognized all of this, at least intuitively, because they lived within it. Many plains cultures understood the significance of finding horses and bison together and used the movements of horses as indicators of where bison could be found. The knowledge that horses, given freedom of movement, would tend to associate with bison was practical information that shaped hunting strategies and camp movements. The relationship between the two species was not just an ecological reality, but a cultural reference point, a piece of landscape knowledge that living closely with the land produces over generations. The Lakota, the Comanche, the Cheyenne, and many other plains peoples had observations about animal behavior that modern ecology is only now beginning to formalize. The understanding that horses and bison moved together was embedded in the practical knowledge of people who depended on that landscape for everything. When European settlement disrupted both the bison herds and the horse populations and broke the traditional relationships that indigenous communities had maintained with the land, that knowledge was displaced and devalued. It is only now, as conservation ecology begins to take interspecies relationships seriously as functional ecosystem elements, that this knowledge is being re-examined, and in some cases, confirmed by formal research. There is something both humbling and encouraging about that. Humbling, because it suggests that a great deal of ecological sophistication has been lost from mainstream Western understanding of how grassland systems work. Encouraging, because it suggests that the path toward restoring these systems runs not only through scientific research, but through the recovery and application of indigenous ecological knowledge that was never lost, only ignored. The practical implications of the horse-bison alliance extend to habitat management in ways that conservation practitioners are beginning to take seriously. In areas where bison are being restored, the question of whether to also allow or encourage feral horse populations is increasingly being asked. The traditional answer in land management has been to see horses and bison as competitors for the same resources and to manage them accordingly, keeping them separate or removing horses from areas managed for bison. But this competitive framing misses the mutualistic dimension entirely. If horses and bison are genuinely mutualistic partners in grassland function, as the evidence increasingly suggests, then managing them as competitors and keeping them separate is actively reducing the ecological functionality of restored grasslands. The vegetative mosaic that their combined grazing creates is not produced by either species alone. The vigilance system that their mixed presence enables is not replicated by single-species herds. The physical infrastructure, the trails and wallows, the insect dynamics, the cross-species information transfer, none of it happens when the species are kept apart. Getting land managers to incorporate this understanding into practice is slow work. Management frameworks change reluctantly, especially when they intersect with politically sensitive debates about feral horses on public land. But the direction of the science is clear. The relationship is real, it is functional, it has deep evolutionary roots, and it matters for the health of the ecosystems that both species inhabit. There are places where you can see versions of this relationship operating today. The Badlands of South Dakota, where a bison herd managed by the National Park Service shares landscape with feral horses in adjacent areas, provides one window. The Pryor Mountain Wild Horse Range in Montana, which is near areas with bison populations, provides another. Theodore Roosevelt National Park in North Dakota has both feral horses and bison in the same park, and while they are managed as separate populations, observers who spend time there report exactly the kinds of associative behaviors that the ecological framework would predict. What you see in these places, if you spend enough time and pay close enough attention, is the same thing that started this story. A herd of wild horses at the edge of water and a bison bull walking in their direction, and neither species reacting with the kind of alarm and flight that encountering a predator or a rival would produce. Instead, a kind of mutual recognition that communicates something more like acknowledgement. I know what you are. You are part of the system that keeps me safe. We have done this together for longer than either of us can know. That wordless recognition, playing out on a windswept plain between two animals of entirely different species, is one of the most profound things that grassland ecology has produced. It is the living residue of millions of years of coevolution, of shared danger and shared landscape, of two very different sensory and behavioral systems, discovering that they complement each other in ways that turn individual vulnerability into collective resilience. The plains created this alliance. The predators refined it. Drought and fire and the long rhythms of the grassland shaped it into something as elegant and functional as anything ecology has ever produced. And for most of the time it existed, nobody who might have written it down in scientific terms was watching closely enough to explain it. It is worth explaining, it is worth understanding, and perhaps most urgently, it is worth restoring, not as a curiosity or a conservation novelty, but as a functional element of grassland ecosystems that North America cannot fully recover without. The wild horse and the bison are not simply icons of the American West. They are not decorative relics of a vanished frontier. They are ecological partners whose relationship built the grassland that both of them and thousands of other species depend on. Understanding that changes how we see both animals, and it changes what restoration of these landscapes actually requires. Stand on a plain where both of them still roam. Watch the horses graze in proximity to the bison. Watch the ears swivel and the heads lift, and the eyes sweep the horizon. Watch the way information moves through that mixed group like a current through water, and understand that you are watching something ancient, something functional, something that was doing exactly this long before there were human eyes to see it. That is the two-species protection system that nobody explained. Now you know.